I'd like to welcome everybody here to session C10 Thursday morning. Analytics with Python, Notebooks, and Informix by Andreas. We all welcome him to the conference and hope you all enjoy his session. Thank you.
Welcome also from my side to everyone. And as Bruce already mentioned, I will be talking about how to do analytics with Python, Notebooks, and Informix. And the first part will be just to give a quick introduction why to use Python with Informix. What's the reason for that? Then talking a bit about notebooks, just in case for anyone who is not that familiar with notebooks yet. And after that, I will look at one very important data structure which is used when doing analytics with Python and databases in general and Informix in particular, and that's the Pandas data frame. After that, I will talk about how to get data from Informix to Python. There are several methods, and I will discuss them with the advantages and disadvantages. And then, well, getting the data to Python is not a purpose for itself. Of course, you want to get insights into the data, and for that, you want to visualize the data and you want to analyze your data, do advanced analytics, some machine learning with it. And that will be the last part of my presentation. Okay. Why to use Python? Python has becoming more and more popular during the past years, and I got some statistics from Stack Overflow. They are doing regularly the developer survey, and for the past 5 years, Python has been what they call the most wanted language, and you can see the question which they have been asking in the above box. But you can also look at this trend slide also from Stack Overflow. It's not as recent as the previous one. It's going from 2012 to 2017. And you see, originally 9 years ago, well, Python was one of many languages, but if you look at the views of the questions asked on Stack Overflow, it has become the most popular language. Of course, one can ask, why is that? What's the reasons why Python is becoming so popular? I think one of the reasons is that it has an intuitive syntax, but I think much more important is that there are a large number of libraries, especially for advanced analytics. For instance, one very popular library is Scikit-learn or TensorFlow for more deep learning, and Keras, which is a bit more high level. Therefore, and that's not the only libraries for machine learning which are available for Python. And also, that's not the focus of my topic today, but there are also many libraries for many other purposes with Python. Then, as I already said in my introduction, when I looked at the agenda of this talk, it has a powerful library for working with data. And that's the pandas data frame, which we will look at closer few slides in the future. And for all the other things which I mentioned, for instance, for visualizing the data, there are also many libraries, and one very popular is matplotlib, which we will also look at. And the next thing which I will talk about is notebooks, which are also becoming very popular nowadays. And there's a very good integration of Python with these notebooks. And the example of notebook which I will be using is the Python, is the Jupyter notebook. And well, why use Python with Informix for advanced analytics? I think for this audience, I do not have to emphasize all the advantages of Informix, like that it's fast, reliable, scalable, whatever. But there are some specific advantages of Informix for this kind of analysis. Informix is optimized for time series data, and many of the advanced analytics algorithms are working on time series data, for instance, for detecting some periodicity in the data, or to predict what the next values in a time series will be. Therefore, time series are very popular with advanced analytics. And another advantage of Informix for these kind of workloads is its extensibility, that you have the option of moving some of the algorithms directly in the database. And of course, there are already good interfaces for Python in Informix. And we will talk about that. But before that, I will also give a short introduction to notebooks in case you haven't using that already. They are mostly used by data scientists, but I would also emphasize they are pretty useful, for instance, for DBAs, because a lot of DBA work can also be done with notebooks. And the advantage of notebooks are that they combine documentation with code which you are writing. And you also see in the same document that's usually presented in a browser, the output of the code when you are running it, including graphical output. The concept of notebooks is actually pretty old. If you are familiar with mathematical software like Mathematica or MATLAB, they have been using this concept of a notebook already for a very long time. But with the increased popularity of data science, they are much more used now by data scientists. They support many languages, as I already mentioned, Python, but also Scala, and also kernels for running your training of your models and so on. For instance, Spark is also very popular for that purpose. And here in my presentation, I will focus on Jupyter notebooks, but there are also other kinds of notebooks, for instance, Apache Zeppelin. How does a notebook look like? Well, this is an example of a notebook. In the top, you see some icons which allow you to work with the notebook. A notebook consists of cells. Cells, that's the gray boxes which you see. And each cell has a number in brackets in front of it, and after that a colon. the number which you are seeing is the order in which these cells were executed, if they were executed. If they were never executed, there is no number. And if a cell is currently executing, you will see a star within the brackets. And the icons which you are seeing at the top, these allow you to work with the cells, to copy the cells, to paste the cells, to reorder the cells, and so on. And you can also store your notebook, of course. But I think one of the most important things which you have icon for is for executing a cell. You can click on a cell and then you either press Shift Return. This will execute your cell, or you click on that icon with the arrow and the vertical bar, which will also execute your cell. You can write code. That's the statements which you see, for instance, in cell 1, import matplotlib, pyplot as plt, and so on. But you can also write a documentation. You write a documentation initially like code. You can do some formatting with that. For instance, you are seeing here, well, in different sizes of the fonts, the documentation. And also that you can see in the last line, you get the output of a cell. For instance, if you just write the expression in a cell, my response dot OK in cell 8 is the expression which is based on the variable which is set in cell 7. And if you just write the expression in a cell, you will get as output the value of the expression. Okay, that's how notebooks work in general. The next thing which I want to talk about is the data frame, which I already mentioned, well, several times. It's the basic concept for working with data in Python. It's providing you data like a table in Informix. For using a data frame, you have specified the import pandas statement. Pandas is the library which contains all the functionality regarding data frames. And here you see an example of an Informix table with 5 columns from direction to value. And what you also get in a pandas data frame, you get the implicit numbering of all the rows. Therefore, you have 4 rows here, which are numbered from 0 to 3, and you have the 5 normal columns and this additional column. Therefore, for someone familiar with Informix and working with SQL with Informix, I think that should be a pretty familiar concept, the data frame. And you have for data frames, we assume that df is a variable of type data frame. You have several operations on that. For instance, you can get essentially a schema of that, like you can get the schema in SQL. For instance, if you type df d types, you get the column names and the types of all the columns. And you can also do a selection of some rows, and you can do a projection on some columns. For instance, if you do a df.log, and then the first parameter is restricting the rows which you get, and in that case we just specify a colon, which means we want to get all the rows, and we want to get the column t-stamp date and value. Therefore, we are projecting on these columns. Therefore, there are many operations just corresponding to SQL statements which you can do on data frames. And even more complicated operations which you are used to from SQL can be done on data frames. For instance, grouping and aggregation. That's the next example on this slide. You are grouping on the column log ESI ID, and you are summing up the value for that data frame. And the next example, up to now we have looked just as an integer representation of the date, but you have also functions like to convert them in a readable format, and there is something like a toDateTime, which converts the datetime column, in that case df. You can say df, then in brackets any column, and you just get the projection for that column, and we want to convert that into a readable datetime format, and something like that is also possible with data frames. Okay, that's the basic data structure which we have to use when doing analytics with Informix while using Python. The next question which I want to investigate is how to access your data in Informix. What options do exist? And well, basically there are three options. You can either use the IfxPy driver. There are other Python drivers for Informix, but I think this is the one which is working best. And besides using a specific driver, you can also use the REST API. And for the REST API, we will see that there are two options. You can either get a table into a data frame via the REST API, or you can execute arbitrary SQL statements via the REST API. And the third option is to use the MongoDB API. I will now dive a bit deeper into the first two options, how to use the IfxPy driver. When you want to do that, well, there are some requirements, and the main difference to the REST interface is that you have to have installed the client SDK, and it has to be at least some version as specified here, which the client SDK has to have. You also have to have specific Python versions. Here still Python 2.7 is mentioned, but nowadays you just should use Python 3. Therefore, Python 3.4 or above is required. And for installing packages, you usually have to use pip, and pip should be in the version 10.01 or higher. And if you are on older versions, the command is given here how you can do that upgrade. And in addition to that, you have to have setup tools installed, which you can do with a pip. Just run a pip install setup tools. That's the requirements which have to be fulfilled for using the IfxPy driver. And now let's look at the example how to use that driver. The first thing which we have to do, that's the first line, we have to import IfxPy. Then we have to import pandas, and the convention is to call pandas PD. Of course, you can give it any name you want, but most examples which you will find or tutorials for pandas will just use PD. Okay, the next line is not necessary. It's just for this example. We introduce a variable table name and we call that train because our training data, which we want to load into a data frame, has the name train1. At train1, that's the Informix table name. Then we build a string for the connection. We specify the server, the database, the host, the service, the user ID, and the password, all separated by a semicolon. And then you also see next how to do error handling in Python. We do a try, assign IfxPy connect with the connection string and two other parameters which we don't need here. And if this is not successful, we will go to the except part and just print an error message and quit. And if the connection is successful, we set auto-commit for this connection, and the line ifxpy.autocommit is showing how to do that. Okay, now we have a connection from Python to Informix. Next, we want to run a SQL statement for getting our data. And we introduce a variable SQL, which is set to select star from. And now that just should be the table name train. What I show here is, in general, if you want to have this more flexible and want to insert different table names, you could use the braces in the string and then replace that with the format and the table name here. Okay, now we have in the variable SQL the statement, and now we can execute that, and we do that by saying ifxpy .exec immediate, and we specify the connection and the SQL statement which we have in the variable. And after this connection is executed, we just want to get the rows, and we do that with fetch tuple, and we will do that in a loop. We assign tu to fetch tuple from statement, and ls will be an empty list. We put all the rows in a list, and just while the tuple, which is set from fetch tuple, isn't false, we will append the value of the tuple to the list and get the next tuple. That's the while loop. And well, now we have the data in the list, and we theoretically could already work with that list in Python. But because many of the libraries which we like to use will work with data frames, we can also convert that list into a data frame. And this is what the next statement is doing. We specify first the list and then the column names and get a data frame by PD data frame. And the last thing which we do is close the connection. This is a simple example how to read data into Informix via the IfxPy driver. The next thing which I like to discuss is how to use the REST API for accessing the data. And the main advantage of the REST API is that you don't have to install any client SDK on any client, because support for REST calls is available nowadays in more or less any language, especially it's available in Python. And the only thing which you have to do, you have to start the JSON listener on the Informix server side. And how you do that, that is shown below. And when you have executed that command, you should get a message like starting the REST listener on port so and so. Okay, that's the only preparation which we have to do. And I think that's a real big advantage, because you no longer have to roll out, especially if you have a large number of clients, you don't have to update any drivers, and you are independent of drivers here. Okay, there are some restrictions regarding the REST interface. I don't want to claim that everything which you can do with the Python driver for Informix you can do with the REST interface, but we will see you can do a lot of it. And first, let's look how to copy a table to a data frame via the REST API. The first thing which we have to do is, again, to import pandas. Then we have to import requests. That's necessary for doing the REST API calls. And we have to import JSON, and we have to get a function JSON normalize. The reason for that is that the REST calls will present the result as a JSON document. And we have to convert that JSON document to a data frame to work with all the data frame functions on that. And for that, we need JSON normalize. Okay. First, we have two variables which we set to user and password. And we have also a variable URL in this example, which we set to the endpoint. And the endpoint is the port and the database on the server where the Informix database is running. And then after the database, we specify the table which we want to load into the data frame. And next, that's the second last line here. we assign the variable myResponse the result of the REST call. And we execute the REST call by requests.get. And the first argument is URL, which we just built. And the second argument consists of user and password. And as I said, this will provide us with a JSON document, which might be the right thing, which we want to use for our further processing. But if you want to work with data frames, we can call JSON normalize on myResponse.json, and this will give us a data frame. Here we see the JSON document, which we get when we select all the rows from the customer table. You see all the known content of the customer table, the first record with Ludwig Pauli and so on. And it's a list with the documents within the list. And after you do the JSON normalize, you will convert that in a data frame. And the advantage of the data frame is if you are using that, for instance, in the Jupyter notebook, by default, you will get such a beautiful table representation without any additional code. And the JSON document you will get in Jupyter Notebook in this format. Okay, this is the way how you just can get a table in a data frame, and then you can do any processing with the data frame which you might want to do. But you can also run a more complicated SQL query. And that's very similar to the above code. We are just using a different URL. In that case, the endpoint starts in the same way. We specify the name of the database, but then instead of specifying a table name, we are saying system.sql and then question mark query equals, and then follows a string. And this string is, as you can see, a JSON document. There are a lot of quotation marks. That's just how everything works here in Python correctly. And the string which follows after query is also put across 4 lines here. First, we are saying $SQL. And after that, we are giving the SQL statement, just as you always write your SQL for Informix. And when you do that, we are doing some grouping and aggregation. You again execute that, or you do the REST API call via request get and specifying the URL and user and password. And then you can do JSON normalize to get it in a data frame, and you are presented the output of the data frame below. You also see that you get by default column names in your data frame. For instance, of course, if you are giving a specific column, it's just the name of that column. But if you are doing something like count, then this will be put into the name of the column. Okay. This are the two options how to use the REST API call for getting data from Informix into Python. As I said, there are some restrictions which you have to keep in mind when you're using the REST interface. For instance, there's a limit on the maximum amount of data which you can get via a single REST API call and so on. Therefore, it's not the solution for everything, but it is a very convenient way for getting data into Python. Okay. As I said, there are many libraries for Python and also for visualizing data. One very popular is matplotlib. Here you see some examples of the visualizations which are available, and matplotlib is working on DataFrames. Therefore, that's one of the reasons why I was converting my data from lists into DataFrames in my previous examples, because when you have DataFrames, you just can use many libraries which are expecting data frames. And let's look at the example how to visualize Informix time series data. We always have had used this TS data V table, which is actually a virtual table, which is the virtual table representation of an Informix table with time series data, because that's the way how you would use time series data in Python. And we are just specifying the URL for that table, like we specified the customer table before. Now we just say ts underscore data underscore v instead. We execute the REST call via request.get with the URL and the authentication as arguments, and normalize the data. We have already done that before, but now we have this data frame df with the time series data, and to visualize that, we first have to import the matplotlib pyplot, and the convention how to name that and to access that is PLT. Then the first thing is just to do a plt.figure, and now we specify the data which we want to plot. And as I said, that's just a very simple example. As you have seen on the previous slide, there are a lot of complicated and elaborate diagrams possible with matplotlib. And if you want to use all these options, it can get much more complicated. But if you just want to simple time series plot it, you are specifying your X and your Y data. For the X data, we are using the timestamp date, and for the Y data, we are using the value. And the final thing is to do a plt.show. And then if you are working in a notebook, for instance, you will get the output which shows the plotted data. Of course, you could make all these things much more fancy. You could change the title, you could change the label, you could change more or less everything. Everything is customizable, but if you just want to use the defaults, you can do it as fast as I just have shown you. Okay, the last topic which I would like to talk about is how to analyze data with Python. And as I said at the beginning, there are many libraries for machine learning for Python. Scikit-learn is very popular, and it supports all the regular machine learning and AI methods. It supports clustering, it supports regression, it supports classification. TensorFlow is more focused on deep learning with neural networks, and Keras is a high-level library for neural networks based on some lower-level networks, on some lower-level libraries. And this is example how to do linear regression. I think linear regression is the simplest machine learning method which you can use. Let's assume we have a data frame, a df, and df.head just shows you the first rows of that. And let's assume we have two columns, and these two columns are somehow correlated, because if you want to do linear regression, they have to be correlated. The data which I'm using here are some measurements from water locations in the US, I think. And I do not remember exactly what column 1 and column 2 are, but one might be something like humidity and temperature, which obviously are correlated. And if you have two such columns, you could do some predictions on the changes of one of the variables, what this will cause for the other one. And for doing that, you first have to import Scikit-learn, and since we want to do linear regression, we import the linear model. And the first thing is we create that linear model we call linear regression with the parameter fit intercept equals true. And then the next line is the actual training of the data of your model with the data from the data frame. And for that, you are saying fit, and with parameters, you are specifying y and x. For y, you are selecting with df.ilog the second column. Why are we selecting the second column? Because we are saying we want all rows, and one is the second column. And for x, we are also selecting all rows, and we are selecting the first column, which is labeled 0. And when we have called that, we have trained our model. And then for linear regression, there are two important parameters which are, well, defining essentially your linear regression model. It's the intercept and the coefficient, and you can print that. And Well, the next step, which I have not shown in the code here, is, of course, to use your model to predict some values, which is also very easy for a linear regression model. If you have more complicated machine learning methods, of course, this can also be more complicated, but I just wanted to give you an impression what can be done with Informix, Python, and notebooks, especially for advanced analytics. Are there any questions? I don't see any questions yet in my chat.
And I haven't seen any. I asked for them to be put in there, Andres.
Okay.
I'd like to thank you all for coming to our session, and the recording and the slides deck will be put up once we have them all available. Thank you, everybody, for attending.
Bye-bye.